Hey everyone, this is Algebra 2, 1.1 homework, expressions and formula. We are going to breeze right on through this. I'm not going to give as much detail as I did for the notes. If you have specific questions on specific problems, bring those up in class. This is just to help you flow through if you're missing one or two of the questions. So we'll jump right into it. I'm going to write down a little cheat sheet over here, PEMDAS. And this is something that I did not mention in the notes. Algebra, or addition and subtraction, as well as multiplication and division, can be done in the same step. They don't need to be done multiplication first and then division. You can do division first and then multiplication. But we'll jump straight into it. For the first one here, we've got 6 plus 8 divided by 2. 8 divided by 2 is division. That's above addition, so we'll do that one first. So we've got 6 plus 4. 6 plus 4 is 10. That's what we're looking for. For this one over here, number 2, we've got a couple sets of parentheses. The most inside parentheses is this one here. So we'll do 4 plus 3 first. That's just a 7. So 14 minus 7, that's all in brackets, divided by 7. 14 minus 7 in brackets is going to be 7 divided by 7 is just going to give us 1. We're done with that one. For number 3, we've got parentheses, and in that parentheses we've got a division symbol and an exponent. Exponents are going to come before division, so we've got to do that one first. So we'll bring everything else down. 2 outside of the brackets. 4 squared is going to be 4 times 4, which is 16, divided by 2. Now that's all that's left in the division, or in the parentheses, is that division sign. So we've got 2 times 8. 2 times 8 is 16. We're all set. For this next one over here, we've got 1/3, and then in parentheses, we've got 4 minus 7 squared. Exponents are going to come first in that parentheses, so we've got 1/3, 4 minus, and 7 times 7 is 49. And the only thing we've got left in those parentheses is that subtraction. So 4 minus 49 is going to give us, let's see, 1/3 negative 45, and 1/3 of negative 45 is going to give us negative 15. For number 5, again, remember, for large fractions like this, the numerator and the denominator, you can treat those as if they're in their own parentheses. So up on the top, we have parentheses. Within those parentheses, we have to imagine. So I'll bring everything over from there first. We've got, let's see, 14 minus, and then in parentheses 2 plus 2 squared is 4. And on the bottom, we've got an exponent, 2 to the 3rd. That's 2 times 2 times 2, so 2 times 2 is 4. 4 times 2 is 8, so we've got 8 divided by 4 down here on the bottom. Bring everything else over. Let's see, parentheses still on the top, so we've got 14 minus 2 plus 4 is 6. So everything we need there. And 8 divided by 4 on the bottom is going to give us 2. So we're done with the bottom of the fraction here. Now we just need to solve the very top part of that fraction. 14 minus 6, we'll just rewrite it here, over 2. And that is going to give us 8 over 2, which is 4. That's what we're looking for number 5. For number 6, we've got a set of parentheses here. That's what we're going to have to tackle first. So let's see. 2 minus 2 squared is going to be, we'll just write everything else down, minus 14 divided by 7 minus 3. 2 minus 2 squared, that's going to be 2 minus 4. Bring everything else down. 5 squared minus 14 divided by 7 minus 3. And that, 2 minus 4, is going to give us a negative 4. And now for everything else, because we have a single value in this, we can get rid of those for now and multiplied. I would actually keep them still in the brackets to make sure we remember it's not 3 minus 4, it's 3 times negative 4. So let's deal with this exponent out here in the front. 5 to the third, 5 times 5 is 25. 25 times 5 is 125, minus 14 divided by 7, minus 3 times negative 4. So 3 times negative 4 is going to give us negative 12. And if we want to, in the same step, we can realize that if we're subtracting this negative here, what we can do here is if we realize we're subtracting this negative 12, it's going to be the same exact thing as adding a 12. So we can do that step here if you're comfortable doing that. If you want to do that in its own independent step, that is absolutely all right. Give myself a little bit of space because we're going to move up here now. The only step before addition and subtraction is this division. So we have 125 minus 14 divided by 7, which is 2, plus 12. And that's just simple addition and subtraction. 125 minus 2 is going to give us 123 plus 12. 123 plus 12 is 135. That's what we're looking for there. This one's going to be a lot of substitution here, evaluating each expression with different values of variables. So the first thing we do is just plug in all the values we've got. W we see is 6, x is 0.4, y is negative 2, z is negative 1. So w is 6 plus 5 plus z, that's a negative 1. And that's just addition and subtraction. So we've got 11 plus a negative 1, which is the same thing as minus 1. So that'll give us 10. W minus 5 minus z, very similar to what we just did. So w is 6 minus 5 minus negative 1. 6 minus 5 is going to give us 1 minus a negative 1. And that's the same thing as plus 1. 1 plus 1 is 2. Let's see, I'll pan back up so we can see those values here. 5x to the third minus y. So within parentheses, we have that 5 times our value x, which is 0.4. And then outside those parentheses is the exponent. That's going to be important. Minus y, which is negative 2. 5 times 0.4 is what we're going to have to do first. We don't want to deal with this exponent yet because we have to handle what's in these parentheses first. So 5 times 0.4 is going to be, and you can use your calculator for this, but that should give us 2. So 2 to the third minus negative 2. And like a few steps ago, I'm just going to rewrite this as plus 2, so I don't get lost in the weeds later. 2 to the third, we've done that a couple times, is going to be 8. That's 8 plus 2. That's going to give us 10. That's what we're looking for there. For this last one, we have all four exponents have showed up to the party. Let's see. We've got negative 1 to the third minus x, which is 0.4, plus y, which is negative 2, to the w, which is 6. So if we have a variable in an exponent spot, same exact thing, you just copy it straight in. And let's start dealing with it. So negative 1 to the third, we'll deal with this exponent first. That's negative 1 times negative 1 times negative 1. We know that two negatives are going to give us a positive, so that's 1 times negative 1. So that's just going to give us negative 1. So we've got negative 1 here, minus 0.4, nothing to deal with that yet, plus negative 2 to the 6. Now, one thing you may have noticed is that if we're taking a negative number and we're raising it to a power, that power is even, we're going to have an equal number of negatives, which means they're going to cancel out. If that doesn't make sense to you, we're going to jump through it all step by step here anyway, so no worries. -2 times -2 times -2 times -2 times -2. That's 1, 2, 3, 4, 5. I'll write another one over here, -2. So these two -2's are going to give us 4. These two -2's are going to give us 4. And those two are going to give us 4. Now it's just 4 times 4 times 4. 4 times 4 is 16. We've still got a times 4 over here. 16 times 4 is going to give us, I'll write this out longhand. We've got 24, 64. Perfect. I'm going to clear out all of this for now. That as well. We just know it's 64, so plus 64. Now it's just -1 minus 0.4 plus 64. It's sometimes easier for me to rewrite these in a easier to read order, so we're just going to do that real fast. 64 minus 1 minus 0.4. So that's going to be 63 minus 0.4, which is going to equal 62.6. That's what we're looking for there. And the last piece of the puzzle. Word problems. You gotta love them. To estimate the width, W, and feet of a firework burst, use the formula W equals 20 AT. A is the estimated viewing angle, and T is the time in seconds from the instant you see the light until you hear the sound. So A is this viewing angle here, and T is the time that it takes from when we see it to when we hear it. Let's see, from the moment you see the burst of light, you count 5 seconds. So that's our T. So we can write that in now. T equals 5. From the moment you see the burst of light, you count 5 seconds until you hear the sound. You estimate the viewing angle to be about 4, and that is this A right here. So we know A equals 4 from right here. And that's all we need. So we know W equals 20, A, which we know to be 4, and the time to be 5 seconds. So now it's just simple multiplication. We've got 20 times 4 right here. That's going to give us 80 times 5, and 5 times 80 is going to give us 400. And that is almost the answer. We want to make sure that for word problems like this, we're writing in the units. So what we're looking for here is feet. So the firework is going to be this many feet wide. So estimate the width. So 400 feet. That is what we're looking for word problems. Got to include those units. That's everything. If you need extra insight for these, talk to your teacher or bring it up in class. We'll see you next time.